Okay, so we're going to kind of break down some of the most common cues using this house as an example. So one of the most common cues is what's called linear perspective, which is the idea that we're used to parallel lines converging or getting closer together at the horizon, so as you move off into the distance. So for instance, if we have train tracks here, we know from experience that train tracks are perfectly parallel with each other. But as it gets farther and farther away from us, those parallel lines start to look like they're connecting. So we know, for instance, if you've got parallel lines in an image, these aren't exactly straight. This is kind of starting to converge inward. So that tends to tell us that the parts where the lines are closer together have to be a little bit farther back than the parts where the lines are farther apart. So this is farther in the distance than this is. Linear perspective. Another cue is texture. So we know that closer objects tend to have more texture visible to us, more detail, than farther away objects. So for instance, if you look at this very cloudy kind of landscape scene, you're able to pick out trees and kind of grass brushstrokes up here in the front, but the back is just like one solid kind of gray shape, right? So we see more texture up front than we do up back. In the same way, again, this is a cartoon, but you're seeing more texture with the stones than you are just with like solid color trees in the back. So closer objects tend to have more texture than farther away objects. We also know shading and highlights can do a lot for us with depth perception. So we know that sun tends to reflect light differently if an object is 3D. So for instance, with the sphere here, if you have a light source up in the top left corner, it's going to light up the part of the sphere that it's closest to, and this part on the back is then therefore going to be in shadow. So we can use shading and highlights to tell us something is 3D. The way that you can kind of see this in this house image is that whereas the front of the house is a very light, light yellow, the side of the house, everything on the right side of the chimney or the wall is a darker yellow. It's shaded a little bit, as are the trees back here. So whereas the things in the front are very light and lime green, the trees in the back are a lot darker. So that kind of is another clue to us that it's a little bit farther back or that there's some 3 dimension to this image. Another famous one is occlusion. So to occlude something means to block it. So we know that distant objects are often blocked by objects that are closer. So for instance, if you see this breakfast scene right here, we can kind of imagine that this coffee cup is farther back in the distance than say the stack of pancakes, because the pancakes we can see as a whole, whereas they block part of the coffee cup. So in the same way here, we can see the house as being in front of the fence, in front of the trees, because the roof tends to block some of the leaves. So we know the trees are behind, back in depth. And then the last one here is what's called relative size. So this is using our prior experience of objects and their sizes for us to be able to compare them and judge how far away we are from that object. So for instance, you might see the cityscape in Paris, France of the Eiffel Tower. You might know from experience that a regular human is not as tall as the Eiffel Tower. So that must mean that this Eiffel Tower is a lot farther back than this woman is. We can judge the relative size of 2 things. Again, also you see a person here in the background. We know from experience that people tend to be roughly, within a range of heights. So comparing this woman who's in the foreground to the height of this person in the back, we can assume that this person in the back must be farther away. And again, in the same way that you see a giant tall house, we know from experience that houses aren't generally taller than trees. So the fact that it's taller than the tree in the back must mean the tree is a little bit farther back in depth. So just to kind of break those down, there are 5 different cues that are all monocular. They only require one eye, just prior experience about how objects typically look in depth. But these cues, monocular cues, are not enough. We could still get tricked by depth. And I'm going to show you a couple illusions that do that. So this is a really famous illusion called the Ames room illusion. So if you stare at this GIF here, you'll notice here that the person who is on the left always appears smaller than the person who's on the right. In actuality, this room is not perfectly parallel. So the person in back, typically like someone's looking through, one focal point, the person on the left is a lot farther back than the person on the right, which is why the person on the right looks taller. And the way they're able to trick your brain and pull that off is by using things like parallel lines, which in actuality are not parallel, but are interpreted by our brain as being, okay, well, that must mean the left side is equal in size to the right side. So this is one famous way that our 5 monocular cues still might have us perceive and be fooled. And this is another one, a famous illusion called the Ponzo illusion. So here's a set of train tracks again. If I asked you which of these two lines was longer, which of these two red lines, most people perceive this back line as being a bit longer than the bottom line. And the reason that we do is because, again, of linear perspective. So we're used to, when these lines converge in the background, that must mean these are farther away. So even though this gap in the train tracks looks really small, we know from experience it must be larger than it looks, because it must be the same distance as this. They're parallel lines, right? So our brain is interpreting that red line in the back as it must be larger because it's in the back. Whereas in actuality, when you put actual parallel lines on here, you'll see that they're really the same exact size. One other illusion that I think is cool, if I asked you which of these 3 cars looks bigger, even I'll still look at this, and to me, this back car definitely is larger than the front 2, right? But they're all the same size. So this is just another example about how we use monocular depth cues, again, of linear perspective, which gives us misleading information about what the depths and the sizes actually are. So now let's move on to binocular cues. True or false? What do you think? Do our 2 eyes receive the same visual information? Do we look at this? Do we get the same input to both eyes?